So, hello everyone. My name is Malik Arslanisar, and I am a TA for this course, Kinematics of Mechanisms and Machines. So, today we'll be discussing the like this is the week 4 tutorial, and we will be discussing some problems which are based on what you have gone during the week's content, and it will help you in solving the week 4 assignment as well. So, let me share my screen first. Okay. So is my screen visible? Is my screen visible?
Yes.
Yes, ma'am.
Okay. Okay, so anybody wants to summarize what you have done during week 4's content? How many of you have gone through the week 4 lectures? Anyone who has watched all week 4 lectures?
Ma'am, I did the first three lectures, not all.
Yes,
Yes.
yes, yes, ma'am. I have completed.
Yes.
Okay, so some of you have watched week 4's lectures, like first 3 or maybe all of them. It's fine because I guess in the first 3 lectures it was about the displacement analysis, like we did for the constraint mechanisms. It was for the robotic manipulators, right? And after that, I think there was just the introduction of velocity analysis. So uh, basically, I have also like there won't be much questions. I'm not sure, but are how many questions are there based on a velocity analysis in the week 4 assignment? If you any one of you have.
Any one of you have? Ma'am, only two there are for velocity
Yeah,
analysis.
because
Yeah, because
uh, yeah, because as I also going through the content, the just the introduction of velocity analysis has been presented in this week, and in subsequent weeks there will be more discussion on velocity analysis. Then you'll get a better idea there. So it's fine if you have watched 3 lectures also, and if you have watched all lectures, that's even better. So any one of you tried any questions?
No, ma'am. Today itself we have completed our video.
Okay, so you have not tried any questions. It's fine because, like in class, you can practice. You have watched the lectures, you can practice, and then it will help you in the solving the assignment. So, when is the deadline of the week 4 assignment?
I think 19th.
19th.
9 days. So you have time, right? You have 4 days. So you don't need to worry about that. So we can discuss some questions, and but please solve along with me. Okay. So, anybody wants to summarize the content? Anybody wants to just briefly summarize what you did in the week? Okay, let me ask randomly. So, Paridhi, you said that you have watched first 3 lectures, right? So, can you briefly tell what summarize it?
Yes, ma'am.
Okay.
Okay. Ma'am, the first three lectures basically sort of told about the displacement analysis of robot mechanisms like two open chain manipulators, and in that also there are different, I mean, problems like forward problem and inverse problem, and also for closed chain robots, parallel manipulators.
Yeah.
And there were also some three chain kind of like RPR
Mm-hmm.
mechanisms. For that also we have solved that inverse and forward problems. Basically, formulas were derived in that.
Yeah, so
Yeah, so
okay. So like in the previous week, what we saw was that like we basically derived the formula for the inverse kinematics and forward kinematics. But I also told you that you do not need to necessarily memorize the formulas. You can always derive it from scratch. But in order to save time in exams, you can like learn the formula for the thetas basically, which are the inputs. So you can calculate theta or s based on whatever the question is asking. So in this week also, basically, yeah, two kind of chains were discussed, which was open chain and a closed kinematic chain. So basically, it was for robots. So the degree of freedom calculation was also shown. So degree of freedom was 2 or greater than 2. And I think for 2 degree of freedom and for 3 degree of freedom, sir has shown you. So basically, all varieties of problems have been discussed, and like you have been shown that how to do the inverse kinematics and forward kinematics for both of them, right? After that, introduction of velocity. What is the sense of velocity in case of rigid bodies? What does velocity in case of rigid bodies mean? How can we relate the velocities between 2 points of a rigid body? That has been shown. We know it from our class 12th also, like from class, since class 12th you have been studying that on a rigid body, if there are 2 points, the relative distance between them cannot change. Okay, that was something which we discussed in the initial classes also of this course, that if there is like 2 points on a rigid body, the relative velocity between them is 0, because basically the distance never changes between them. Okay, so sort of that idea has been now elaborated here. So I think now we can start discussing the questions. Okay, so that will make this idea more clear. So is my screen visible? Yeah.
yeah. Yes, ma'am.
Okay, so the first problem is that you have been given a RP manipulator. Okay, RP, why RP? Because this here is an R pair and this is a prismatic pair, right? So this is a RP manipulator. So it has a 2 degree of freedom, and this end effector is attached to this link. So what has been asked is that the actuator inputs for the given RP manipulator are theta is equal to 41.67 degree and s is equal to 1.56 meters. So basically the s and theta, they have been provided, the actuator inputs have been provided, and you have been asked the position of the end effector. Right, so basically it is a forward kinematics problem. It's very straightforward. You have to calculate the xe and ye of this manipulator, and the dimensions L1 is equal to 2.4. Okay, so this link is given as 2.4 meter, and this alpha here, it is given as 70 degree, right? So do you want to give it a try? Anybody wants to say what, how should we approach this problem? um, Anybody? So how we do it?
Ma'am, we'll find the coordinates of the end factor.
Yeah, so that
Yeah,
is the
so that.
question, but like how will we do it? Okay, so let us discuss. Like if you even remember the formula, or if you know how to do it, I'll give you a minute. You can try it and tell me what you're getting. Come on, give it a try. Are you guys trying it out?
Yes, ma'am.
Okay.
Okay.
What about others?
Ma'am, XE value is coming 3.165 and Y is coming 0.855.
Yeah. So, yeah, your answer is correct. What about others?
I'm trying to find man.
Okay. So, we can discuss the solution then. Okay. So, see, the problem given to us here is something like this, right? This is the y axis, this is the x axis. So, this is a revolute pair here, okay, and this is a prismatic pair here, and after that, this is the length s, and let me say this is my end effector, and here xe and ye I have to calculate. Now this length is L1, so it is given as 2.4. I will directly write the value. This theta is given as okay, let me write it as theta, but theta is given as 41.67 degree, right? And this s here, it is given as 1.56. These are the values that have been given to us. And what about this angle? This angle here is phi, right? Now and this angle here, this is alpha, right? This angle has been given as alpha. So this is the information provided to us. Now again, as I said that you can either like memorize the formulas, which is not a good idea because sometimes the orientation of the manipulator will not be given straightforward. So you might get like if the orientation is simple, you can solve it by geometry. If you feel that you cannot solve it by geometry, then you can maybe refer directly to the formulas because they will give the correct answer anyways. So what will we do here is that we need to find the x coordinate and y coordinate of this point. And already this is something which I know, right? This is something which is 2.4 cos of theta, this length here. Now I need to figure out this length, right? And this length will be equal to this length, right? So if I figure out this length, it means this length will automatically be known. And this here is this whole length here, it will be 2.4 sine theta, right? 2.4 sine theta, this vertical length. Now if I find out this length and subtract it from this length, then I will get the y coordinate, right? Because this length will be equal to this length. So basically I need to figure out these two lengths and then subtract it from this in order to get xe and ye. So okay, now this length is known to me because it is 1.56. So if I figure out this angle, which is nothing but phi, right? If I figure out what is the angle phi, then I'll be able to uh, calculate it. So look here, if I draw a horizontal like this, right? This whole angle is alpha, but this line is parallel to this line, so this angle here is theta, so this angle will also be theta, right? Measured in anti-clockwise direction. Okay, so here theta is measured in anti-clockwise direction, and always remember that whenever we measure angles in anti-clockwise direction, it is considered as positive, and here alpha is shown in negative direction, so it is clockwise. Okay, alpha is measured clockwise, so it is uh, negative. Okay, you can remember these things. So, and from geometry here also you can see that this line is parallel to this line because both are horizontal, so this angle will be equal to this angle. So basically alpha is this angle here, right? Alpha will be this angle. This angle will be alpha. Sorry, not alpha, this angle will be phi. So basically phi can be written as theta, okay, which is positive theta minus alpha. Now alpha is greater than obviously theta, so this will be a negative quantity. So, but when we put it in the coordinate equation, there is cos and sine. Okay, it will be cos of theta minus alpha and sine of theta minus alpha. So the negative and positive sign will be taken care by cos and sine itself. Okay, so basically now we have figured out this phi here. So this is here, this is phi. Okay, now it's straightforward. We can write xc as what? This length plus this length, right? So I will write it as L cos theta plus this is S cos of phi, right? This length is S cos of phi, and that will be equal to this. Okay, now what about ye? Ye will be, this whole length is L sine theta, right? Now we have to subtract this length from it. Okay, but as I said that we have already taken the sign will be taken care by this, so we don't need to subtract it, we will just add it. Okay, so we will write it as plus S sine phi. Okay, now this sine phi will be theta minus alpha, and we know that theta is small and alpha is greater, so it will automatically come out to be minus here. Okay, so this length will automatically be subtracted from it. Okay, so what is this here? L cos theta. L is nothing but, sorry, L is 2.4 cos of 41.67 degree plus S is 1.56 and cos of theta is 41.67 degree minus what is alpha? Alpha is 70 degree. Okay, so here you can see that cos of negative angle is still positive, so this term will be plus here only, and it will be added. And in this case, for calculation of y coordinate, it will be 2.4 sine of 41.67 degree plus S is 1.56 sine of 41.67 minus 70 degree. Right, now here you can see that sine of a negative angle is minus sine of that angle, so this term here will be subtracted. Now if you calculate it, okay, so this is coming out to be, okay, I do not have space here, but let me write it here only. If you calculate this, xc is coming out to be 3.17 meter and ye is coming out to be 0.86 meter. Okay, I have done these calculations, you can check it once on your own. Okay, clear till here? Anybody has any doubt?
No, ma'am.
Okay, so now let us move to the next question. So So here the question is that the relation 5.70 sine theta plus 4.55 cos theta is equal to 6.98 is true for the given RR RPR manipulator. So we have been given a 2R RPR manipulator for theta less or equal to 45. Okay, so in this question we have been given a condition. Okay, the condition is that whenever theta is less or equal to 45 degree, this relation will hold good. Okay, 5.70 sine theta plus 4.55 cos theta is equal to 6.89. So basically you can figure out theta from this relation. What it is telling us next is that determine the position of the end effector, okay, at an orientation angle of phi equal to 65 degree. Assume L2 is equal to 16, L3 is equal to 18 and D is equal to 4. So basically we have been given a, okay, people are still joining. So this L1 has been given, okay, L1 is not given, sorry. This L2 has been given to us, okay, and it is equal to 16 centimeter. This L3 has been given as 18 and this D has been given as 4 centimeter, right? And this phi is also given 62.25 degree. Now what we need to figure out is the XC and Y coordinates, which is pretty simple. Okay, how shall we do it? Anybody wants to tell how will we do it? See, just like the previous question, ultimately we want to figure out this, which is y, right? And this
Uh, X is equal to L1 cos theta plus D cos phi.
xc is equal to L1 cos theta plus, not L1, L2.
D
L1 is the base, it is L2 cos theta,
sorry,
right?
L2 cos theta and plus D cos phi.
Okay, so you mean if this length is there, L2 cos theta, then you are just adding this length.
Yes, ma'am. So I said about L1 plus D cos phi.
No, because L1 is only this much and D is only this much. You have to add this length also, no, in between.
Yes, L1 plus D cos phi.
Okay, you're telling you will add L1, the whole L1, then D cos phi.
Since L1 is not given, so we have to calculate from L2, ma'am.
Okay, you can
Mm,
do it that way. So
mm.
that is also correct. So what I will do is simply this length is, this here is L2 cos of theta, right? So this is L2 cos of theta. Now I can add this length. This length will be what? L3 plus D cos of phi, because this angle and this angle will remain same because this line is parallel to this line, right? This angle is phi, so this is also phi. So I'll add L2 cos theta plus L3 plus D sin phi, D cos phi, okay? So it will be, the XC coordinate will be L2 cos theta plus L3 plus D cos phi, okay? What about y? Y can be similarly found that this length is equal to this length and it will be equal to L2 sine theta, right? And this length will be equal to what? L3 plus D sine phi. So y will be L2 sine theta plus L3 plus D sine phi. Is it clear? Now here you can see that L2, L3, D and phi all are known. So only x, e, y, e and theta is the unknown. But theta you can calculate from this equation, right? Theta can be found out from this equation. And then you can put theta here and you can calculate x, e and y. So quickly try to do it and tell me what you are getting. Okay. If anybody has already solved, you can tell me your answers. Otherwise, try to do it. Did you understand what you have to do here?
Yes, ma'am.
Okay, so please do it and tell me what are the values you're getting. First, tell me for the values of theta, because from this equation you can find out theta. Tell me what is the value you are getting for theta using equation 1. Okay. Anybody got the value of theta?
It's coming minus 38.58.
Minus 38. I guess you're making some mistake, because it should not be minus 38. See, let's do it here. What is the relation given to us? The relation given to us is why it's not able to.
5.7 sine theta
Okay,
plus 4.55 cos theta is equal to 6.89.
okay, wait a minute. Yeah. So the relation is given as 5.70
7
sine theta
sine theta
plus
plus
4.55 cos theta
is
equal
equal
to
6.89.
6.89. So it is in the well known form a sine theta plus b cos theta is equal to c. So you know that tan of theta by 2 will be equal to what? A plus minus under root of a square plus b square minus c square upon b plus c, right? So it implies tan of theta by 2 will be equal to 5.70 plus minus under root of 5.70 square plus 4.55 square minus 6.89 square upon 4.55 plus 6.89, right? And then from here theta by 2 will be tan inverse of these two, 5.70 plus minus whatever. Please evaluate this quantity and tell me what you're getting here.
2.39174.
2.39174. Okay. uh, and what is the next one?
Ma'am, actually you are asking about the whole answer angle.
No, not the angle. What have you calculated this quantity here? This, what is this expression coming out to be? This expression, did anyone evaluate this? Has anyone calculated it? Okay, you can do it in one shot also if you are doing it like that. So you can write it basically.
Ma'am, the final answer is 35.27253 degree. Uh,
Yeah, so from here two values will be coming. So theta 1 which I calculated is 32.258 degree, and the next value is coming out to be 70.545 degree. Okay, this is what you will get here. Now it has been mentioned that this equation or this relation holds good only for theta less or equal to 45. So this value we don't have to take. So only this value will be there, right? Uh, Sorry. Okay. So what did we calculate? So theta will be taken as 32.258 degree, right? Now we can put it in the equation. What was the equation? Y is equal to, I am not able to see the screen, so please can you repeat it? It was
By
L2 cos theta
L2 sin
square
theta. Sorry,
16,
XC is equal to L2 cos theta.
yeah, 16 cos of
Theta.
32.258 degree plus L3.
L2 L3 plus D cos
Okay,
phi.
L3 plus D. So D is 4 and L3 is 18. So it will be 22 cos of, what is phi? Phi is given as 65.25 degree, right? Similarly, Y will be equal to, okay, so, it will be, Y will be L2
At
sine
the place
theta
of cos, only sine will be there.
16 cos of 32.258 degree plus 22 cos of, sorry, not cos, it will be sine, right? So 22 sine of 62.25 degree. So what is XE coming out to be
At
from here?
both place, sine will be there. 16 sine 32 in
Yeah,
case of
sorry,
YE.
yeah, sorry, I'm sorry. This will be sine. Uh, yeah, now it's correct. So what is XE coming out to be? XC will be 22.74 centimeter. Okay, and this here when you evaluate it, it will be equal to 28.52 centimeter. Okay, I have done it. You can also cross check it on your own. Okay,
Okay,
any
ma'am.
doubt till here?
No, ma'am.
Okay, it was pretty uh, so now let's move to the next question then. Okay, this one I want you people to try, because see the location of the end effector, it's similar to the configuration that has been given in the first question, right? The location of the end effector of the manipulator here is given. Okay, so XE and YE have been given to us. If the actuator input theta can be expressed as A sine theta plus B cos theta equal to 10.83, calculate the value of A plus B. Assume L1 is equal to 14.5 and alpha is equal to 85. Do you want to give it this question a try? Anybody who wants to say how will we do it? See, you will first write the equation for xc and ye in terms of L1 and S. Okay, like similar to what we did in question number 1. Okay, even the equation will be similar, only the coefficients will be different because L1 length is maybe different, yeah, and alpha is different. So the equations will be similar to just as we did in question number 1. After that, you will try to write those equations in form of a sine theta plus b cos theta equal to c. But remember that a, b and c will be different. It need not necessarily come out to be equal to 10.83. So you will call that equation as a dash sine theta, b dash cos theta, c dash. Okay. Then you compare both the equations and find the value of a and b. Okay, so please give it a try. You can use the equations from the first question and give this question a try. So let me write the base equations for you. Xc is given as 22.4 and y is given as 8.6. So we can write 22.4 is equal to 14.5, which is basically this length, 14.5. This here is 85. So 14.5 cos theta plus plus s is given. Okay, s is not given, so it can be written as s cos of theta minus alpha, and alpha is also given. So, and the second equation will be 8.6 is equal to 14.5 sine theta plus s sine of theta minus alpha. Now here alpha is given, so you can substitute that, and s is not given, so you will try to eliminate s from these equations. So that is the catch. Okay, that is how you approach a question. So try to solve these equations and tell me in what form you are getting it. Anybody got the equation in terms of a dash sine theta plus b dash cos theta is equal to c dash?
No, ma'am.
Okay, you're still trying to do it? Are you at least trying?
Yes, ma'am. Yes.
Okay. So what you can do, if you are not still getting it, I will give you a hint. You can write it as 22.4 minus 14.5 cos theta. Okay, take this to right side. and is equal to s cos of theta minus alpha. And here you can, okay, let me not do it again. I can, let me do it here only. So what you can write is 22 minus 14.5 cos theta is equal to s cos theta minus alpha, and here you can write it as 8.6 minus 14.5 sine theta is equal to s sine theta minus alpha. Now you can clearly see that if you divide the both the LHS and RHS of both equations, this s will be automatically cancelled. So that is what we will do. We will write it as 22 minus 14.5 cos theta upon 8.6 minus 14.5 sine theta is equal to cos of theta minus alpha upon sine of theta minus alpha. Right. Now in this equation, the alpha is also known, and theta is the only unknown. So you can express this as in terms of a dash sine theta, and like this, a dash sine theta plus b dash cos theta is equal to c dash. You have to basically expand cos of theta minus alpha. You know the identity cos of a minus b, sine of a minus b, so you can uh, use those and expand it.
Uh, Ma'am, like in lectures where I've told expression for S, ma'am, if we put the values of alpha and x, y, and y in that expression, we
Mhm.
get a relation between sine theta, cos theta, and S. And if in question also we have been given a similar kind of relation. So can we find the value of S from there?
Yeah, if you can.
Yeah, if you can.
The point
The
is,
point.
can you please mute
Can you
yourself
please
because
mute
the
this because
voice is
the
going echo when I speak. Okay. So if you are able to express, if you are able to express any relation using s also, like a dash sine theta plus b dash cos theta equal to c dash, that is fine. Okay, then we can compare these coefficients and you can get the answer. If you have tried it that way, are you getting any relation between sine, cos and s?
ma'am, that way I can get the value of S as 10.83 if it is correct. So,
Okay,
ma'am, okay. Then the relation will, if we put the values, it will come out to be for XE, like 22.4 equals to 14.5 cos theta plus 10.83 cos of theta minus 85 degrees. Basically, we have to solve this similar way that you're doing.
okay, but the relation you are getting, what did you say? Please say that again. It is coming out to be what?
What? Ma'am, if we take that relation in lectures,
Mm-hmm.
S value of S will be this 10.83. I guess because in the even that sine theta and cos theta is given,
So you are
so
telling
it
it will
should
be,
give same answer. I
it will
guess.
be a sine theta plus some b cos theta equal to s.
Yes, ma'am. It is
Okay.
coming S is equals to 22.4 sine theta
Mm-hmm.
minus 8.5 cos theta.
Okay, so you are
Okay,
getting
so
the
you are
value
getting
of
the
a
value of
as 22.4, right?
yes, ma'am, 22.48 and B as 8.532.
No.
Minus, but in minus. Yeah, but B's values in minus 8.532.
Minus 8.532. And what is the sum coming out to be? A plus b has been asked.
Yes, ma'am.
So what is the sum coming out to be? Can you tell? I just forgot the
Just
values
forgot
of
the value. 13.948.
13.948. No, that is not correct. See, one thing is there, it it might have been coincidental that this value is coming out to be equal to s, because if from this side I think there will be theta minus alpha. So uh, what in the relation is it coming out to be a sine theta plus b cos theta equal to s? Because I think you are making some mistake. It shouldn't be like that, because this theta minus alpha will come. So you
Ma'am,
have
actually the relation is given xe sine theta minus ye sine
okay.
theta
Let me write
whole
xe
divided by sine alpha
minus ye.
cos theta
Mm-hmm.
whole divided by sine alpha
Is equal to
is equals to s.
okay. So you calculated from this the value of s, right?
Yes, ma'am.
Okay. Then then you have to put s sine alpha on this side, right? So it will not be, if s is coming out to be 10.3 from this relation. So if s is coming out to be 10.3 from this relation, when you express it in this form, it will be xe by sine alpha sine theta minus ye by sine alpha cos theta equal to 10.3, right? Then this coefficient you calculated and this coefficient you calculated, right?
Yes, ma'am.
So it should come, yeah, this should also come correct, but I don't know why you are making a mistake then. Because if this is the formula from where you have calculated it, it should be correct, because it is coming out in this form only. So you can check it later on, because it should come that way also. Okay. But let me show you how I have done it. Then maybe you can cross check your solution if you're making any mistake, right? Now, when we express it in this form, let me use the board. Okay. So it is coming out to be 22.4 minus 14.5 cos theta upon 8.6 minus 14.5 sin theta equal to cos theta, and I'm expanding it, cos 85 degree plus sin theta sine of 85 degree, and here it will be sin theta cos 85 degree minus cos theta sine 85 degree. Okay, sine of theta minus alpha. Yeah, so when you simplify it, it is coming out to be 8.6 sine 85 degree minus 22.4 cos 85 degree into sine theta plus 22.445 sine 85 degree plus 8.6 cos 85 degree into cos of theta equal to, this one is coming out to L1 sine alpha, which is 14.5 sine of 85 degree. Okay, now here you can see that this is coming out to be my a dash, this is coming out to be my b dash, and this is coming out to be my c dash. Okay, this equation will simplify to this. Now let's evaluate a dash. So can you tell me what is the value of a dash? It's 8.6 sine 85 minus 22.4 cos 85. Okay, so it is coming out to be 6.615. Okay, I have already calculated it. And b dash is coming out to be 22.45 sine 85 plus 8.6 cos 85. So it will come out to be 23.064. Okay, and c dash is coming out to be 14.445. Okay, now this is the equation I am getting, 6.615 sine theta plus 23.064 cos theta is equal to 14.445. Okay, now if I compare it with the original equation, which is a sine theta plus b cos theta is equal to 10 point, what was it, 10.83, right? From here you can see that if I divide this 14.5 uh, here, so it will be 6.65 upon 14.5 and 23.064 upon this, and on the right hand side it will become 1. Similarly I will make it here, then I can compare the coefficients. So 6.615 upon 14.445 yeah, will be equal to a upon 10.83. So tell me, what is the value of a you are getting from here? uh, Array, is that gone?
4.95.
Oh, okay. It's 4.95. I hope you have written that. I think that's gone. What about b? You have the equations, right? So b will be, okay, sorry, I somehow that got discarded. I don't know why. Anyways, I can write it again. So what is the value of a you're getting?
17.29.
Yeah, that is b. B is equal to 17.29 and a is equal to 4.959. Okay, it is from those relations only. Okay, a is equal to nothing but a dash by c dash into c. Okay, which was equal to a dash was 6.615 upon 14.445 into 10.83, right? And b we got from here, b is equal to b dash by c dash into c. So it is equal to 23.064 upon 14.445. I hope you are following this, okay? And from here you get these two values. Now a plus b is equal to 4.959 plus 17.29, which is equal to what? 22.25. Okay, is it clear? Any doubt?
No.
Hmm. Okay, this is the question. So yeah, the answer will be 22.25. So let's move to the next question then. Can anyone read this out?
Yes, ma'am. In the given 3 RPR manipulator, L1 is 8.2 centimeters, D is 3.5 centimeters. The location and orientation of the end effector are E, XE and YE,
Yes.
15.2 and 18.7 centimeters, and phi given as 60 degrees. Find the value of S2 and S4 in centimeters.
Yeah. So how should we do it? Anybody? See, there can be various approaches to doing it. You can use the formulas that have been given to you. I have done it simply by looking at the geometry, okay, of the manipulator, because this is a planar manipulator. So you can simply solve it that way also. Let me do one thing. let me just add another slide. Some Okay, now this is better. So now we have been given that this length is equal to 8.2, right? And this length is also equal to 8.2 because both the lengths are same. Then this D has been given as 3.5. Okay, and the location of the end effector is also given, 5.2 comma 18.7. The phi is also given, which is equal to 60 degree. Now we need to find S2 and S4, right? See, the coordinates of this point are 0. Okay, so if I figure out the coordinates of point A, right, I can simply write xa square plus y square is equal to S2 square, right? So S2 square will be what? Xa square plus y square. So basically I need to find out xa and ya. Now how can I find xa and ya? See, the coordinates of end effector are given to me. So this is xe and ye. I can simply write xe as what? 2 xa can be written as xe minus 2d cos of phi, right? This whole length is xe, and if I subtract this length from it, it will give me this coordinate of a. So I can write xa is equal to xe minus 2d cos phi. Similarly, ya can be written as this whole length is ye, so I have to subtract y from ye this length. So I can write ye minus 2d sine of phi. Why? Because this angle is phi. This is phi, this is phi, and this is 2d. So it will be 2d sine of phi. Now xe you know, ye you know, d you know, phi you know. So quickly tell me what is the value you are getting for xa and ya. Quickly. It will be equal to 50. So xa will be equal to 15.2 minus 2 into 3.5 cos of phi is 60 degree, right?
Right.
So
It's 11.7 and 12.63.
yeah, it is 11.7, and ya is coming out to be 12.63. Now what is the value of S2 then? S2 will be under root of 11.7 square plus 12.63 square, which is coming out to be under root of 296.60, which is equal to what? When calculated, it is coming out to be 17.22, right? So S2 you
So
have
S2
sorted
you
out.
have.
Now what about S4? S4 also you can similarly find out. That is even more simple. Why? Because here the coordinates are L1 comma 0, and for B you can similarly find the coordinates. B will be what? Xe minus d cos phi, and B will be ye minus d sin phi, because only d will be subtracted once. The hypotenuse here is only d, so this will be d cos phi, this will be d sin phi, so this one will be subtracted. So here xb is equal to xe minus d sin d cos phi, and yb will be ye minus d sine phi. So what is xb and xa coming, xb and yb coming out to be? Do it and tell me.
It's 13.45 and 15.66.
Yeah, it is 13.45 and 16 point, no, sorry, not 15,
15.66.
15.66. Yeah, it's 15.66. Okay, so how will you write now? S4 square is equal to 13.4. Let me do it here. Okay, so you can write S4 square is equal to 13.45 minus L1 is what? 8.2 square plus YB is 15.66, and this is y coordinate of Q is 0, so it will be like this. So S4 is coming out to be, please calculate it, under root of,
It's plus minus 16.51.
yeah, so it will come out to be 16.51, because we will not take the minus one. Okay, S is the length of the link, so length cannot be negative. So this is how we find it. So both S2 and S4 have been calculated. So any doubt in this question?
Ma'am, in the S4 equation,
Yeah,
like 13.45 minus 8.2 square.
yeah, it is, it is, let me write it like, you want to figure out this length, right? So you will subtract the coordinates of point Q and B, because S4 is the length connecting, basically S4 is the distance between points Q and B, right? So you can write S4 as x coordinate of B minus x coordinate of Q whole square plus y coordinate of B minus y coordinate of Q whole square. Now xb we have figured out as 13.45. xq is what? xq is nothing but this L1, and that is given as 8.2. So I subtracted that 8.2 from here. Now YB we calculated from here. YB is equal to 15.66, and YQ is 0, because this is on the x-axis itself, right? So the coordinates of this point are L1 and 0. That is what we have done. Understood?
Yes, ma'am.
Okay. Okay, so let me shift this. So, okay, this question I want you to give this a try. Okay, think over it, then we'll discuss. The question is that the dimensions of 2R manipulator are shown as L1 equal to 3.2. So this length is given as 3.2 meter, and L2 is given as 1.6 meter. Okay, these two lengths are given. Now we have to determine the area of workspace of the manipulator if the rotation of actuator theta 2 is restricted, as that theta 2 can only go from 60 degree to 300 degree. Okay, so uh, can anyone tell me how we do this question? See, if there were no restrictions, okay, what we could do is that we would say that this length, when the end effector or the second link has been fully extended, it will be L1 plus L2. So the workspace will be a circle of this radius. Okay, let me do it. Yeah, so the circle will be L1 plus L2 when the end effector is fully extended. But when the end effector is folded, basically this link comes over this. Okay, it is something like this. Then it can come to this configuration also. Okay, this is a revolute joint, so it can come here. Okay, now this was 1.6, this whole length is 3.2, so this length will be L1 minus L2, which will be 3.2 minus 1.6. Okay, and 3.2 minus 1.6 is equal to what? I guess 1.4 1.6, it will be 1.6. So that time the radius will be, let me use a different color. So this is when the end effector was fully extended, and when the end effector would fully contract, this will come to this length. So basically this will be 1.6, and this length will not be able to reach by the end effector. Okay, it will be able to reach here, it will be able to reach here, and it will be then able to reach any of this area. So in that case, okay, if there were no restrictions, the area would be pi of basically the area of the larger circle minus the area of the smaller circle, which you can easily find by, you know, that area of a circle is pi r square. So first you will consider the complete radius L1 plus L2, and you will subtract pi of L1 plus L2 whole square. That would be the area of the large circle. Then for the inner circle, the radius would be L1 minus L2. So the area would be pi of L1 minus L2 whole square, and you would subtract those areas and you would get the workspace, right? This is how you get the workspace for a 2R manipulator. But here there has been given a restriction. The restriction is that this link length cannot completely extend. Why? Because this angle theta 2 cannot go beyond 60, right? And here also it cannot go beyond 300. It means on the opposite side also it cannot go 60. So it will be something like this. The end effector will be like this. Now what will happen in this case? Can someone tell me? What will effectively happen in this case? Okay, what happens is that, let me use a, can I change the color? Yes. Yellow is fine. In our first case, our effective radius was L1 plus L2, right? The effective radius was L1 plus L2. But here now the manipulator, this manipulator link number 2, it cannot go beyond this. Okay, it cannot become completely straight. So this will be the manipulator orientation, and this will be the, like, this will be the link 1, this will be the link 2. So now this thing is out of picture. Okay, so what happens is that in that case effective radius will be this. In first case we considered the radius of the circle to be L1 plus L2, but in the case given in this question, the effective radius will be this. Okay, so you will have to calculate what that is equal to. Now we know that this length is equal to what? The link number 2, it is 1.6, and this length is equal to let me draw it nicely. Yeah, so In this case, this link length is 3.2. Now this link length is 1.6, right? And this angle, let's call this angle here is 60. So this will be my effective radius now. So how do we calculate this radius? We can apply the cosine rule, or we can simply write that this vector is equal to this square plus 2ab cos theta, right? So I can find it from there. So this r max will squared will be equal to 1.6 square plus 3.2 square minus 2ab, sorry, not minus, it will be plus 2ab cos of 60 degree. Can you calculate this value and tell me what you are getting?
Four point eight, ma'am.
4.8. This length is coming out to be 4.8. Wait, let me calculate it once. No, it's coming out to be 17.98. Okay, 17.98 r max square is coming out to be this. Okay, now what will be the area of the circle when the radius is this? That will be pi of r max square, right? So it will be 3.14 into 17.98. What is this coming out to be?
$56.4.
Yeah, 56.297. Same meter square, yeah, because the distances are given in meter, lengths are given in meter. So this is the area of the larger circle. Now, in case of the inner circle, there will be when the link will be overlapping on this, okay, when we fold it, and the effective radius is L1 minus L2, that time there is no restriction on theta 1, right? Theta 1 can move completely 360 degree. So there will be no change in the area calculation of the inner circle, okay, that is this circle. So that will be simply equal to what? Pi of r minimum square, which is equal to pi into what is r minimum? 3.2 minus 1.6 whole square. Can you tell me what this value is coming out to be?
It's 8.0384.
Okay, so this is coming out to be 8.0384,
384.
right? Now what is the uh, workspace? Basically this larger area minus this smaller area where the end effector cannot go. So what is the difference between these two? 56.297 minus 8.0384. So it is coming out to be 48.25. Okay, so let me write it here. So workspace area, okay, let me do it in next page. So workspace area will be a max minus a, let me not write it that way, a calculated when the radius is r max minus a calculated when the area radius is r min. So it will be 56.297 297 minus 8.03 8.0384. Was it like that? Yeah. So this is coming out to be 48.2548 meter square. So that will be your workspace area. Okay. Let me.
Can you please tell why we'll find this R max?
Okay.
Okay.
Let me do it here again so that you understand. See, if we have a manipulator like this, it has one link like this, another link is like this, right? If there is no restriction on this link, the movement of this angle, say theta 1 and this is theta 2, right? Whatever this forms with the first line, here theta 2 is 0. So how do we calculate workspace? First we see what when the links are fully extended, okay, up to which point it can reach. So it can reach to a maximum of L1 plus L2. Okay, it cannot go beyond that. L1 plus L2, it cannot go beyond that. So it means this end effector can reach up to this point. Like this circle it can trace, it will become its workspace. Now, like our hand, see, this is our hand. So you can imagine that this can move like this, right? But my hand can move like this also. So this is also in its workspace. So similarly, I have to check key outer radius, this is covering L1 plus L2, but up to inner how much it will go. So we can see that by bending it completely. If the end effector is bent completely, up to which length it will go. In the question it is given this length is 3.2, this length is 3.2, this length is 1.6. So the outer the radius of the outer circle which it can trace will be L1 plus L2, that will be 3.2 plus 1.6, that will be 4.8. So up to a radius of 4.8 it can cover that area. But when we turn it inside, this whole length 3.62 minus this length, that is 1.6. So this length here it will become 1.6. Now the end effector cannot go beyond this point. Why? Because it has a length of only 1.6 meter. Even if you bend it completely 180 degree, you cannot cover this area, you cannot go into this area. Workspace is basically where the end effector can work. In terms of robotic manipulators, sometimes we have a robotic arm which has a gripper attached, and that gripper can move in space. So in space it can move around this boundary, but it cannot go beyond this boundary, right? It cannot go beyond this boundary. So this will be subtracted from its workspace. That is the first case. So basically it can reach only in this portion. Understood till here? Now,
Now,
huh. Now in the second case what happens? In the second case, we have been mentioned that this length is L1, okay, and this is theta 1. So theta 1 पे कोई restriction नहीं है, theta 1 can move anyway. But this theta 2, it cannot go below 60, so it has to be 60, then it can change to any orientation, and up to 300. So up to 300 means that this whole angle is 300, so means this angle is also 60 degree, right? Then it will be 360. So the end effector can be in the orientation like this, and like this it can cover the whole area. But in the first case, if you visualize, this was the first case, this was the circle formed, right? This was the radius was L1 plus L2. But in this case the radius will not be L1 plus L2, again it will trace a circle only, right? You will calculate it that way only, but this time the effective radius will not be L1 plus L2, because it will be a component of L, basically L1 plus a component of this length. So it will be less than L1 plus L2. That is why we calculate this radius, R max it can go. And that is how we do it. Okay? Clear?
Yes, ma'am.
Yeah. So you can maybe visualize it when you study these things for the first time. You are not able to understand it clearly. So you can visualize it, think over it. Okay. Watch some animation videos in YouTube so that you can get the understanding of the what is workspace. Okay, and how the robotic manipulators move. So let's move to next question. In the given open chain manipulator, okay, L1 is 1.4, L2 is 0.8. Okay, so the link lengths have been given, and they find the actuator inputs necessary to place the end effector at xe and y equal to 1.55 and 1.2. See, this is a simple inverse kinematic problem, right? You have been given the end effector coordinates, you have been given the link lengths. All you need is to find out theta 1 and theta 2. Okay, so please do it by yourself. I'll not spend much time in this question because it is very straightforward. So try to do it and tell me, put your answers in chat box, and I want every one of you to do it. Okay. Okay, I will give you 4 to 5 minutes to solve this question. Meanwhile, I'll get some water for myself. So please try to solve it till then. Yeah, so anyone did it?
Yes, ma'am.
Yeah, what is
Yeah, what is
the answer you're
the
getting?
answer you're getting? Ma'am, theta 1 is coming out to be 34.76 and 42.96, and theta 2 is
Mm-hmm.
10.38 and minus 17.91.
Repeat your values again. What is theta
What
1?
is theta 1? 34.76 and 42.96.
No, I guess
No,
you're
I
making
guess
a
you.
mistake. And what about theta 2?
10.38 and minus 17.91.
No, the
No,
values
the
are not
values are
correct.
not correct.
I think you're
I
making some
think you make.
calculation mistake because this is a straightforward question, and if you go by the procedure that has been shown in the class, you can get the answer. But the correct answer is, okay, let me write what are the two values of theta 1. Theta 1 can be 17.324, or it can be uh, what else can it be? It can be either 17.34 or 59.995, and corresponding to these values, corresponding to 17.324, theta 2 will be equal to 56.3108, and corresponding to the 59, theta 2 will be 303.689. So does someone's answer match with these? Okay, I think you all should work on your calculation, because see, you'll have to appear for the exam also. So maybe even if you're doing the correct procedure and you make some mistakes, which happen, I also make some mistakes when I was solving this solution. My answer also came incorrect for the first time. It's because we tend to make calculation mistakes on calculators, or even while doing it by hand. So that's not an issue if you know the concept, if you're able to apply the concept correctly. That is important, but then work on your calculations. Okay. So you know the standard procedure which has been shown in the classroom. Okay. Basically, you'll first write the xe and ye in terms of these angles. So we know that we can draw a we can draw a line parallel to the x-axis, and then this angle will be theta 1. So we know that if we write the coordinate xe, it will be equal to L1. L1 is given as 1.4 and L2 is given as 0.8. So it will be L1 cos of theta 1 plus L2 cos of theta 1 plus theta 2, right? Which can be written as xe is 1.55 is equal to 1.4 cos theta 1 plus L2 is 0.8 cos of, array, what happened? Yeah, 0.8 cos of theta 1 plus theta 2. Okay, let me keep it like this. Okay, and similarly y can be written as, y will be what? L1 sine theta 1 plus L2 sine theta 1 plus theta 2, which will be ye is given as what? 1.2, right? So L1 will be 1.4 sine theta 1 plus 0.8 sine of theta 1 plus theta 2. Now, if you follow the basic procedure, what you can do is you will take this cos term to this side, cos theta 1 term to this side and sin theta 1 term to this side. Basically you subtract it from the left hand side and right hand side. So and then you will expand this cos theta 1 plus theta 2 and sin theta 1 plus theta 2. Then you follow the procedure, then you get an equation a sin theta 2, a sin theta 1 plus b sin theta 1, sort of that. And because theta 1 and theta 2, it will be eliminated, then you will get an equation in theta 1. You can solve it and then you can get two values of theta 1. Then you can substitute it and get two values of theta 2. Okay, you can do it that way also, but for me I think this question is like we can solve it in a different way also. So what I want to do is that instead of taking this on the right hand side, I will square on both sides and add them. So let's see what happens. Okay, so for first equation 1.5 square, okay, is equal to 1.4 cos square theta 1 plus 0.8 square, okay, both are square, cos square theta 1 plus theta 2, right? Then twice AB. Okay, I expanded this, I squared both sides. So 2 into 1.4 into 0.8 cos theta 1 cos theta 1 plus theta 2, right? And what will be the second equation? 1.2 square is equal to 1.4 square sine square theta 1 plus L2 is 0.8 square sine square theta 1 plus theta 2. Then okay, let me take this a little bit up. I okay okay, let it be. Wait a second. Yeah, so okay, so the first term squared, the second term squared, then plus twice 1.4 into 0.8 into sine theta 1 and sine of theta 1 plus theta 2. Any doubt till here? Did you understand what I did here? Is it visible to you?
Yes, ma'am.
Okay, to everyone, right? See, now you can see here that I will add first both these equations. So I will add them and I will write it as 1.5 square plus what will be the second term? 1.2 square. It is 1.55 square plus 1.2 square is equal to, now look clearly, this sine square theta 1 and this cos square theta 1. If I combine these terms, what will it be? We know sine square theta plus cos square theta is equal to 1. So this 1.4 square I can take common and these two terms will add and make 1. So it will be 1.4 square, right? Similarly, here this is cos square theta 1 plus theta 2 and here it is sine square theta 1 plus theta 2. This shouldn't be minus, this is plus only. I don't know why I wrote it like minus. So this is 0.8 square cos square theta, 0.8 square sine square theta. Again, if I take 0.8 square common, then cos square theta 1 plus theta 2 plus sine square theta 1 plus theta 2 will be equal to 1. So this will remain as 0.8 square. Now, look at these two terms. It is 2 into 1.4 into 0.8. Here also it is 2 into 1.4 into 0.8. So I can take that out. It will be 2 into 1.4 into 0.8. Okay. Now what remains inside is cos theta 1 and cos theta 1 plus 2. So it will be cos of theta 1 into cos of theta 1 plus theta 2 plus what remains from this second, sine theta 1 and sine of theta 1 plus theta 2. So sine theta 1 and sine theta 1 plus theta 2. Right. Now you know this identity, cos A cos B plus sine A sine B. It is equal to what? Cos of A minus B. So I can write it as cos of A minus B theta 1 plus theta 2 minus theta 1. So I will clearly get it in terms of theta 2. So now 1.55 square plus 1.2 square minus 1.4 square minus 0.8 square upon this coefficient 2 into 1.4 into 0.8 will be equal to cos of theta 2. Now when you solve it, this is coming out to be, theta 2 is coming out to be 56.3108 degrees. Okay. Now what next? Next we need to find theta 1. So for that, look here. Now let me use another pen first. If I connect this point with this point, right, and let me call this angle as alpha. Okay, this angle is theta 1, this angle is alpha. So basically I know xc and y, right? xc is equal to what? 1.5 and y is equal to what? 1.2. So this xc and ye, I can write the tangent of this angle, tan of alpha plus theta 1 is equal to perpendicular by base, right? So perpendicular is 1.2. Do you agree with this? Do you agree with this? Now here, from here we can find theta 1, but the condition is that alpha should be known. So how can we find the alpha? Now look closely in this triangle. So yeah, here we know this length, we know this length, and we can then write this length also, right? Because two sides are known and we can write this length also, and then we can apply the cosine rule here to find out the cos alpha. Cos alpha will be what? Cos of alpha will be this 1.4 square. Okay, let me just name them. This is O, this is A, and this is B. So it will be equal to cos OA square plus OB square minus AB square will be equal to twice cos alpha into OA into OB. Okay, basically the cosine rule I am applying here. Did you understand this? Let me do it here only. So you can write twice cos alpha into OA into OB is equal to OA square, this length, plus OB square minus AB square, right? So Now we can write it as cos alpha is equal to OA square plus OB square minus AB square upon 2 OA OB. What is OA? Please respond. What is OA? 1.44.
1.4.
Right.
Right.
What is OB? OB will be,
OB will 0.8.
sorry,
Sorry. 0.8.
no, AB
No,
will
no.
be
AB will be
0.8.
0. AB will be 0.
AB will be
AB will be
0.8. What is
0.8.
OB? What is the length OB? OB will be, see, this point's coordinates is 0 comma 0 rho, and this point's coordinates is 1.5 and 1.2. So OB will be 1.5 square plus 1.2 square. So it will be 1.5 square plus 1.2 square minus AB square. What is AB? AB is 0.8. This length is 0.8 upon twice OA into OB. So that is 1.4 into 0.8. Can you calculate alpha from this equation and tell me what is the value you are getting? What is the value of cos alpha?
And 5.
Sorry? Oh, this is not OB. I'm sorry. I'm really sorry. This OB is, if I write OB here, OB will be under root of 1.5 square plus 1.2 square. Right? This is OB again. I accidentally wrote AB here. Now you calculate it. Let me make it clear. Little bit clear. So it will be 2 into OA is 1.4 and OB will be under root of 1.5 square plus 1.2 square. Now calculate cos alpha. What is cos alpha coming out to be? So cos alpha is coming out to be 0.9314 and alpha will be equal to 21.3356 degree, something like this. Now coming back to here, tan of, so you can put that value here now, okay, and you can write alpha plus theta 1 is equal to tan inverse of 1.2 upon 1.5. What is this coming out to be? This is coming out to be tan inverse of 1.2 upon 1.5 is 3.38.659, something like that, okay.
Okay. Mama, alpha was coming 19 point something.
19 point
19
something.
points. By the way, it was 1.55, so maybe that will make a change.
Yeah, maybe that
Yeah,
will
maybe
change
that.
because I've taken it as
I've taken it
1.5.
as well.
But there is only, when I calculated it, only minor differences coming in the answer, like in the decimal point. But yeah, if it's 1.55, please take it 1.55 only. Okay. So now alpha is 21.33. So what will be theta 1? Theta 1 will be 38.659 minus 21.335 and theta 1 is coming out to be 17.324. Okay. Understood till here?
Yes, ma'am.
Anyone has any doubt till here? So corresponding to this theta 1 we calculated, corresponding to this theta 2 we got theta 1 as 17.3241. Now see, there is another configuration of this possible for this point, right? If the end effector position is here, there is another configuration possible by which we can reach to the same point. That is something like basically the mirror image of this. Now this angle was alpha, right? So what will we do? Yeah, if this angle is alpha, this angle will also be equal to alpha. Okay. So in this case, the theta 1, okay, for the this is the first configuration which was given in question. That was the first configuration for which we solved and got these values. Okay, this and this was for the first configuration. Now for the second configuration, okay, there is some okay, I lost my network, sorry about that. So yeah, what was I saying is that, yeah, this was for the first configuration. Now for the second, array, what is happening? Okay, is my screen visible?
Yes, ma'am.
Okay, so for the second configuration, this will be your theta. It will be theta 1 plus 2 alpha. Okay, so for second configuration, you can write theta 1 2 as theta 1 which we calculated in the first configuration plus 2 alpha. What was the theta 1 in the first configuration? It was 17 point,
17.3214.
okay, it was 17.3214 plus twice alpha. What is alpha? We just calculated, it is 21.3356. So what is this coming out to be? Tell me fast. This is not square, this is for second configuration. What is this coming out to be? It is 59.995. Okay, this is the theta 1. Now everybody got this?
Yes, ma'am.
Now look for theta 2. See, here theta 2 is measured with respect to the link 1. So basically this is theta 2, right? Yeah, this is link 1, this is link 2. So okay, no, this whole angle should be measured, right? So this is not measured. If this is my link 1, okay, this is my link 1 and this is my link 2, so this angle will be measured from this line up to this line. Okay, so see here also this was link 1 and this was link 2, so the angle between link 1 and link 2 is measured as theta 2 and not with respect to horizontal. So similarly here also this is link 1 and this is link 2, so this angle will be measured in the second configuration, right? So what is this angle equal to now? Can someone tell me? since this is the mirror image of this configuration, this was alpha, this was alpha, this was theta, so this will also be equal to theta 2. So in the second configuration, the angle will be 360 minus theta 2 calculated from first configuration. So theta 2 in second configuration will be 360 degree minus theta 2 in first configuration. So it will be 360 degree minus, what was the first theta 2 in first configuration?
56.31.
56.31, right? Okay, so it was 56.31. So if you calculate it, it is coming out approximately equal to some 303.6892. Okay, so this is how you get for the theta 1 for the second configuration, and theta 2 for the second configuration. That was what I showed in the answer. Corresponding to this, that is the theta of 2, and corresponding to this theta 1, this is the theta 2. Okay, you can verify it with the similar procedure, like the procedure which sir has followed in the class. Okay, not using geometry, just the analytical method. As I said earlier, you can express it in the form of a sine theta plus b cos theta, something like that, and solve the, like this basic procedure we do for inverse kinematics, and then get these values, and then you can compare the solution. Okay, anybody has any doubt in this? So this is a relatively easier method. I took time to explain it, otherwise when you solve it, it does not take much time. It is clearly visible that
Ma'am, with the formula, theta 1 is coming out to be 57.6 something, and another theta 1 is coming 17.8. I mean, like, the other theta is a little
ah
bit changed.
yeah, that is because I have calculated 1.5. No, it was 1.55, so that is why there will be little. But if the first two digits are correct after decimal point, you should not worry. Okay, it is
No,
almost
ma'am,
correct.
there is a difference of 2 degree. I mean, like, yours is coming 59 point something, and it's coming 57 point something.
Oh, 59 and 57.
Yeah, ma'am, other one is coming 17.8. It's a little same, but the second
Let
one
me
is 2 degree difference.
let me check. It shouldn't be. But in that case, your what is your alpha? See, our alpha was also coming out to be different. Then I have multiplied alpha with 2, and then I have added theta.
No,
So
but
that
in
is,
that, alpha isn't given. I mean, I did with that formula based.
yeah, but I am telling that since in the calculation of alpha, it was I took 1.5, and that is why there came a difference in alpha. Now then I multiplied alpha with 2, so the difference will also become double. Then I added theta. Okay,
Yes,
that's
ma'am.
why there is difference in theta 1. I will try to do it once again. Okay, the same question using 1.55, because I have solved it myself, but I used 1.5, not 1.55 in the solution. So I will check it once. So I think then there should not be this difference. Okay, it will come out to be same. Okay,
Yes, ma'am.
so now two questions are remaining. So okay, this question looks huge, but the solution was very simple. Yeah. So the coordinate of point A in given RPR manipulator is XA and YA equal to 12.14 and 13.43 centimeter. Circle 1 has its center at Q with radius S4, and circle 2 has its center at A with radius D. Okay, so these are the two circles shown. Sorry. Yeah. So circle 1 has its radius as S4. Mm, circle 1 has its radius as S4. Okay. Okay, what is this happening? Is it visible? Hmm. So you can see circle 1 has been traced with the radius as S4, link length S4, and the red circle, which is this circle 2, for it the radius is this length D, right? It is evident, quite evident from the diagram. Now what is it asking? Now both of these circles intersect at 2 points, right? uh, okay, I'm sorry about this. I don't know why this is happening. Let me just make this big. Okay, for the time being. Yeah, so here you can see that uh, this both circles will intersect at 2 points. One point is here, which is known which has been mentioned as B1, and the another point is here, which has been called as B2. Now these are the 2 points where the uh, this mechanism or robotic manipulator can be assembled, right? Now also B1 and B2 are the positions of B point B on link AE. Okay, for two possible configurations of mechanism, it's just the same thing which I said. If the two possible orientations of end effector for S4 equal to 22.5 are phi 1 equal to 53 and phi 2 equal to 170.55, then find the coordinates of the point B1 and point B2, and the dimensions of manipulator are given. So L1 is given, D is given. So basically what the question is asking, that this link length S4 is also given to us, and these link lengths have been given, D has been specified. Now for the two configurations there will be two different phi, right? So both of the phi have been given in the question. Now it is asking what will be the x the x and y coordinate of point B1 in the first configuration, and what will be the x and y coordinate of the point B in the second coordinate, this second configuration. So how do we do it? It is basically uh, it's simple, as the coordinates of point x, this a, are given. So x and y a are given to us. Now in the first configuration, we know that we can write the coordinates of xb in terms of xa with the relation we have already seen so many times, like x of b will be uh, xa plus d cos alpha, right? And yb will be x ya plus d sine alpha, right? This we have seen so many times. Similarly, we can write the coordinates in the second configuration in the similar manner, just the value of phi will change. Okay, so let me do it in next page. I hope you understood the idea of the question, that is important. So here we have two cases. Case 1, when phi is equal to 53 degree, and case 2 where phi is equal to 170.55 degree. Now we know that xb can be written as xa plus d cos phi, and yb can be written as ya plus d sin phi. Okay, this we have been doing in so many questions. Now here also x, so here phi will be phi 1, and here coordinates of x don't change, but phi 2 changes. So these two equations, you know all the values. Can you calculate it? Can you calculate xb for case 1? X is given as 12.14 plus d is given as 11.3 and cos of 53 degree. and YB, quickly calculate it, and YB is given as YA, which is 13.43, plus D is given as 11.3, and sine of 53. What are these two values coming out to be? So when you calculate, this is coming out to be 18.94 and this is coming out to be 22.45. And similarly for second configuration, when phi is given as 170.55, it will be 12.14 plus 11.3 cos of 170.55, and YB will be equal to 13.43 plus 11.3 into sine of 170.55. So XB in the second configuration is coming out to be 0.99 and YB is coming out to be 15.29. So the question looks pretty complicated, but it's not. Okay, it's simple. Again you have to write the basically the coordinates of this point B, okay, in terms of A, and the coordinates of A are given in the question only. So that is pretty straightforward. Okay, anybody has any doubt in this? Otherwise we can do the
No, ma'am.
hmm?
No, ma'am. No doubt.
Okay, so let's do the last question for today. So find the velocity of point B in meter per second if velocity of A is equal to 5 and velocity of C is equal to 11 and alpha and beta are given. Alpha is equal to 28 degree and beta is equal to 75 degree. Anybody wants to say how we can do it? Those who have studied. So see, let me explain the diagram first.
We can resolve the
Yeah,
vectors and then find.
yeah, basically that is how we do this question. Let me tell you here. We know that VA will have a component along this, right? What will that be equal to? That will be VA cos alpha, and which is equal to 5 uh, cos of 28 degree. Something is happening to my screen. Let me. Okay, I hope now it won't make problem. Okay, so now VA cos this component here, okay, is equal to VA cos alpha, which is 5 cos 28. What is this value coming out to be? 4.414 meter per second. So this is 4.414 meter per second, right? Now what is the velocity of C given as 11, right? And what is the velocity of C along this component? It will be Vc cos of beta, which is equal to 11 cos of 75 degree. What is that coming out to be? Quickly.
2.84.
2.47.
Yeah, this is 2.847. Right, so this is 2.847. Now we know that if we extend this here, okay, So if we keep the this component of velocity of c, okay, let me call it vc. Say this line I am calling as n, so it will be vcn. So okay, and the component of b, the component of velocity of a is here, so let me call it va m. Okay, now we know that velocity of b is going to be somewhere, like, since this is the component here, so we will make a plane perpendicular to it, and velocity of point b along this line can be anywhere in this on this line, okay, which is perpendicular to this bc line. Okay, so I have extended this bc line. Okay, let me call it as obc. Now any line perpendicular to this velocity of the velocity component of b will lie here. Similarly for, okay, this, similarly for this ab, I have extended in this way. There will be one, this line perpendicular to this, and we know that the component of b along this line should lie somewhere here. Now these two have one intersection point, so the velocity of b is going to be like this. Okay, it is pretty simple. Now how do we figure out velocity of b? Let's call this angle as theta. Okay, so we know that from here velocity of b, vb cos theta, should be equal to vcn, which is equal to this. So vb cos of theta should be equal to 2.847. Now what is this angle? This whole angle is 180 degree. So 180 degree minus theta minus 105 degree. So this angle we will get from here. Let me call it as phi. Okay, this angle is phi. So phi will be 75 degree minus theta. So what will be the component of b along this? It will be vb cos phi is equal to va. So vb cos phi is what? Vb cos of 75 degree minus theta is equal to va. What is va? What did we calculate va as?
4.414.
Yeah, 4.414. va cos alpha, yeah, 4.414. Now we can use this equation and this equation. We have two unknowns, theta and vb. So we can use two equations, two unknown, to find out. Now let me do it in next page. Okay, I'll show you how. Okay, so yeah, now vb cos theta is equal to 2.847 and vb cos of 75 degree minus theta is equal to 4.414. Now we can divide them and it will be cos theta upon cos of 75 minus theta is equal to 2.847 upon 4.414. Okay, which is equal to 0.644. Now you can write it as cos theta upon 0.644. Okay, or maybe let's keep it there. Cos theta is equal to 0.644. Now look close, I am expanding this. Cos of a minus b will be cos a cos b plus sin a sin b. Okay, now I can divide cos in the whole expression. So dividing by cos theta, This will be cos theta upon cos theta is 1 is equal to 0.644 into cos 75 into cos theta into divided by cos theta will be cos 75 plus sin 75 and cos sin theta divided by cos theta will be tan
tan
theta,
theta.
right? Now let me take it here. So 1 upon 0.644 is equal to cos 75 plus sin 75 tan theta. Can you calculate tan theta from here? Tell me the values quickly. Use calculator. When you solve it, tan theta is coming out to be 1.339. So theta is coming out to be 53.25 degree. Now it's simple. We know that VB cos theta was equal to 2.847. So VB into cos of 53 degree is equal to 2.847, which implies VB will be 2.847 divided by cos of 53 degree, which you calculate and it comes out to be 4.75. I have done it. You should also do it yourself. Understood till here? Are you getting the same values?
Yes, ma'am.
Okay. So I think we have already extended the class by 20 minutes. So I'll end today's lecture here. If you have any doubts or if you sometimes try any solution and you're not getting still the correct answer, you can email me. Okay, if you have any problem in your solution or anything, you can always email me. That you can find in the uh, sheet, also the Google sheet that has been shared with you. Other than that, anything, any doubt which you want to discuss right now? Otherwise, I'll end the class. Any
No,
question?
ma'am, no doubt.
Any question? Okay. So, okay, thank you so much for attending this session. Have a good day.